All right, ladies and gentlemen, this is your grid calculation part of your review. So this is to help you with your workout problems for the test that you'll have on circuits. The number one key to getting these problems correct is to make sure you can identify series versus parallel versus complex. This very first one that we're looking at here, circuit one, goes from your voltage source, and then it goes through all 6 resistors and comes back to your voltage source. It has one pathway, so that makes it a series circuit. Because it's a series circuit, you need to know your rules, and with a series circuit, everywhere IT is the same. Okay, once you find the total current, you'll know the I everywhere. So we can write down some basic information just from our picture. We can write down that resistor 1 is 3 ohms, and I'm just going to write an ohm here so I don't have to write that all the time. Then 2 is 6, 3 is 9, 4 is 1, 5 is 3, and 6 is 12. Because this is a series circuit, we are just going to go ahead and add all of these, because to find your total resistance, it's R1 plus R2 plus so on and so forth. So when you add 3 plus 6 plus 9 plus 1 plus 3 plus 12, you end up with a total of 34 ohms. Okay. Also, from our picture, though, we can write that the voltage is 100 volts. And I'm going to put a V right there. Now, the information that I've written in black is roughly like variables. So you get credit for just making sure that you list what you already know from the picture. And then we solved for the 34 ohms in blue using our total resistance formula. Now, we could find our total current. So I'm going to come down here and I'm going to say I equals V over R, and this is Ohm's law. My total V was 100. Then I'm going to divide by 34, and I'm going to get an answer of 2 point, oh, and you can't read that in there, so let's make it blue again, 2.94, and this is amps now. Now, the thing to realize is that for current, remember we said it was the same everywhere. If that's true, then that also makes this 2.94 and this 2.94, 2.94, 2.94, 2.94, and 2.94. Okay, now to solve for all of the V's, you're going to do V equals IR. All right, so V, let's actually do blue. V equals IR. So you'll take these two and multiply, these two and multiply, these two, these two, these two, and these two. All right, so I went ahead and calculated those and wrote them by multiplying the current times the resistance. And you should be able to double check that, because if all of these are correct, when you add all the voltages, when you do V1 plus V2 plus V3, so on and so forth, you should get your total voltage for a series circuit. So that should roughly come out to about 100. It might be a little more, a little less just because of rounding. But that's how you do a series circuit. So key really is to remember that current is the same everywhere in a series circuit. All right, moving on. This next one, we have multiple pathways, and so multiple pathways are going to mean that we have a parallel circuit. Since it's parallel, we have certain rules to remember as well. Parallel means that voltage is the same everywhere. Okay, so we can write some basic information down for our variables. So I'm just going to write ohms and volts and amps. Oh, I didn't do something on my previous one. I'll go back and do that in a minute. Okay, my resistance for 1 is 6, 2 is 12, 3 is 18, and 4 is 3. And my total voltage we already know to be 60 volts. Again, that's identifying your variables. All right. So we can automatically say, because it is a parallel circuit, that voltage is the same everywhere. So 60 goes here, 60 goes here, 60 goes here, and 60 goes here. Okay. We could find our I by doing I equals V over R. So we'll go ahead and take V and divide it by R, and V and divided by R, V divided by R, and V divided by R. And that'll give us, so if you do those calculations, you end up with the numbers that I have written here, which are 10, 5, 3.33, or 20. Now there's two different ways to find the total current. You could say that IT equals I1 plus I2, so on and so forth, and you could do that. And if you do that, you would get an answer of 38.33. Now you could also use this formula over here that we had in white of I equals V over R, but you first have to find the total resistance. To find the total resistance in a parallel circuit, you're going to go ahead and do 1 over R1 plus 1 over R2, and then so on and so forth. And then you're going to take the reciprocal of whatever you get as that answer. So we're going to take 1 over 6 plus 1 over 12 plus 1 over 18 plus 1 over 3 equals, and then we're going to take the reciprocal of that number. When you do that, you should get 1.57 ohms. So if you use this white formula over here that I circled now in blue too, and said 60 divided by our 1.57, you would come up with 38.22, which both of these amps are similar, so I would accept either way depending on how you showed your work for how you solved that. Now, what I left off on both of these was the power. So I need to go back and do the power on each one of these. Well, we learned in the last unit that power equals V times I. So you're just going to find the total power by doing the total voltage times the total current. So we're going to take these two right here and multiply them together in circuit 1. So 100 times 2.94 is 294, and that's watts. Right. Same thing here. We're going to take our 60. You could do it with either one of these numbers. I'll give you answers for both. It is 2,293.2 watts, or it's 2,299.8 watts. Either one of those would be a correct answer depending on which unit you gave for your current. Hopefully that simplifies these. This might also have helped with your homework if you needed help with it. Okay, moving on, I'd like to go ahead and talk about your next set of grids on your review. Okay, these sets here have multiple pathways, but also have resistors that are in single pathways. Since they are both sets, these are going to be complex circuits, which means we have to use parallel and series rules. Okay, so we went ahead and wrote down our information. I'm going to transfer it to my grid over here. So R1 is 4, and R2 is 8, and R3 is 6, and R4 is 3. All right, I'm also going to mark which resistors are in series and parallel. Okay, my series resistors are going to be in R1 and R4. They're in series. My parallel resistors are in 2 and 3. So I've marked those in pink and blue so that I can deal with them accordingly when I get to them. Now I can come down here on VT and go ahead and write 36 volts because I already know that, and that's just a given variable. Okay, so I want to go ahead and find my total resistance first because I think that would be the easiest thing to work with. So I'm going to start off, and my RT is going to have to be, I'm going to go ahead and have to find an equivalent resistance. So these two resistors right here, I'm going to have to find what their equivalent resistance is. So I'm going to find RE. RE is for parallel is 1 over 8 plus 1 over 6. When I do that, I'm then going to have to take the inverse. And when you do the inverse, you come up with 3.43 rounded ohms. Okay. I'm going to then take that number, because my RT is going to be my equivalent resistor plus R1 plus R4, because now those are in series with each other. If that's the case, then I'm going to take this 3.43 plus resistor 1 is 4 ohms. And then I'm going to say plus my resistor 4 is 3 ohms. So I'm going to end up with 10.43 ohms as my total resistance. So I had to use series and parallel rules. Now I can solve for my I, because I is going to be V over R. So I can take 36 divided by 10.43, and I end up with an answer of 3.45. And this is in amps. Now remember, for a series circuit, for series, let me write it in pink, series, the I is the same. And then for parallel, the V is the same. Okay, so if that's the case, I've now found my total current. So I can plug that in everywhere I have a series circuit. So this is going to be 3.54, and this is going to be 3.5 or 45, excuse me. 3.45 and 3.45 on resistor 1 and 4 because they're both series. Now I can use my V equals IR to solve for the voltage of each of those. So I'm going to multiply 4 and 3.45 and get 13.8 volts there. And 3 times 3.45 is going to give me 10.35 volts there. Okay. Now, here's the thought process. I start off with 36 volts. All right. When I go through R1 and R4, I know how much voltage those are going to have to use. So I'm going to subtract 13.8 and I'm going to subtract 10.35 volts from 36. That's going to leave me with 11.85 volts. That means that in this section right here, there is 11.85 volts used. If 11.85 volts is involved in this section, then that voltage goes to both R2 and R3 because it is a parallel circuit. So I'm going to write that for their voltages. So 11.85 goes here and 11.85 goes there. All right. If that's the case, I can then use this formula of I equals V over R again to solve for my parallel currents, which I'll get 1.48 and 1.98. Okay. That should be how you would solve these. If I asked for total power, again, power is going to be, and we'll write it here, P is equal to IV. So you could solve all of these just by multiplying the current and the voltage together. Okay, so I went ahead and did all of that, and it should have popped up in blue on your screen in all of the powers. Hopefully that makes sense, because really all you're doing is voltage times current. Okay, well, let's look at this next one. It is also a complex circuit. We can automatically write that our VT is 24 volts. And we can, I'm going to go ahead and write over here that resistor 1 is 4 ohms, resistor 2 is 5 ohms, resistor 3 is 3 ohms, and resistor 4 is 12 ohms. The first thing we have to start with is identifying what series, parallel, all that kind of stuff. All right. Well, 2 and 3 are in series with each other, but that series is in parallel with 4. Okay. And then our, oh, I switched them. Let me rearrange that coloring. Sorry. Okay, I want to make it blue. So blue here is parallel. And then we want to go to the pink, and R1 is just a basic series. Okay. So we have to start off with these two. They're in series with each other, so we just have to add them together because the rules are RT or this RE is just going to be R2 plus R3 because they're in series. So when we get that equivalent resistance, that's going to be 8 ohms. We're then going to do another equivalent resistance for that parallel set there, which is going to be now 1 over 8 plus 1 over 12, and then we're going to take the inverse or reciprocal of that, which is 4.8 ohms. We can now find our total resistance by doing R1 plus this new RE, which is going to be 4 plus 4.8, which is going to give me 8.8 ohms. So I can come over here and write on my total resistance that it is going to be 8.8 ohms. Now I can use I equals V over R. And when I do that, I'm going to say that I have 24 divided by 8.8, which is going to give me 2.73 amps. Okay, well, for a series circuit, the current gets to be the same everywhere. The only one that is a true series circuit is the one we have in pink, which is resistor 1. So we're going to write 2.73 amps right there. When we do that, we can now find the V up here by doing V equals IR. So if that's the case, I can now say that that is going to be 10.92 volts. Hopefully everybody's followed me so far with what I've done for series, and then I've solved for R1 because that's the only true series I have. All right. So with that, I can now solve for my parallel voltage because I had 24 volts minus my 10.92 volts, and that would leave me with 13.08 volts. Okay. R4 is in parallel with R2 and 3. So R2 and 3's voltage will total 13.08, and R4's voltage is going to be 13.08. I can't do anything about how the voltage is split yet on R2 and 3, so I'm going to wait. But I can go ahead and do I equals V over R for R4. So 13.08 divided by 12 is going to give me 1.09. Well, I know the total current is 2.73. If I subtract this 1.09 current that's here, that tells me what current is running through my series circuit of this part of the resistor. Okay, that's going to leave me with 1.64. So the amount of current that's in both of these is 1.64. All right. Because that total amount of current, that one color that's in that number that's in green plus the number that's in blue equals my 2.73, and that's what it has to equal for the current of that part of the circuit. All right. Now I can go back again and do my V equals IR and solve for my V's in R2 and R3. That will come out to be 8.2 and 4.92. Again, your power, you're going to use this formula up here that I'm about to bubble in white of P equals VI. And you can solve for all your powers on this circuit. And those numbers should have popped up as blue numbers in the grids and at the total. And so I would recommend going back over these again. If you kind of got lost as I was going along, start them over at the beginning. Look at how I solve for total resistance. Think about how the pieces tie into each other, and then look at the rules for series and parallel and make sure you're following them. That's key to passing this test well. Good luck, and if you need help, come see me.